Good morning. Welcome to my presentation, Westward Drift of African Ionospheric Plasma Depletions over Srinagar, Jammu and Kashmir. The outline of my presentation is as follows. We will have a brief introduction of the ionospheric irregularities. Then we'll discuss about the instrument used in the study of these ionospheric irregularities and the image data processing. Then we'll have some look at observations and the results, and which we'll discuss in the later section. So let's start with the brief introduction of the ionospheric irregularities. The frequently observed irregularity features in the F-region ionosphere are the medium-scale traveling ionospheric disturbances, called as MSTIDs, and the equatorial plasma bubbles, called as EPBs. The MSTIDs typically are wave-like structures, which are often observed in the mid-latitude regions of the ionosphere. The wavelengths having wavelengths of the order of 50 to 1,000 kilometer, and horizontal propagation velocities of 50 to 500 meters per second, and exist with the time periods of about 15 to 90 minutes. Based on the time of the observations, we have three classes of the MSTIDs, that is daytime, nighttime, and desk time MSTIDs. In general, the plasma bubbles are confined to the equatorial regions, which are mostly believed to be generated by the Rayleigh-Taylor instability. Under extreme conditions, the Rayleigh-Taylor instability can create irregularities of the equator, but there are very rare exceptions for this case. Similarly, the equatorial spread F density depletions can reach high altitudes and extend to the equatorial anomaly latitudes. In this study, we provide an evidence of the westward drifting plasma depletion structures, which extend from the mid-latitude regions towards the low mid-latitude transition region in the Indian sector, that is Jammu and Kashmir, Srinagar. So this is the instrument called as All Sky Airglow Imager, which captures the images of the airglows at different azimuth peak altitudes through multiple wavelength interference filters. As an example, we use the 630 nanometer interference filter for imaging of the ionospheric irregularities with the azimuth peak height at 250 kilometer. This All Sky Airglow Imager consists of the fisheye lens having 180-degree field of view. It has a temperature controller and a filter wheel control, which contains the multiple wavelength interference filters. And also it has a data detection and storage. The data in the form of the images, and these images are called as the raw images, as these are not suitable for the retrieval of information from them directly. These need to be processed before we look for the irregular events in these images. In the processed images, we correct them from, in the raw images need to be corrected for certain intensity effects like Van-Roentgen effect, and we provide the directions to the sides of these images and convert the pixel correspondences into the geographic coordinates. Here we have shown the kilometer, the x and y axis represent the distance in the kilometers, while the 0 point represents the overhead Srinagar. So these are the plasma irregularity structures which are seen on May 5, 2019. These images are 630 nanometer OI images, and in these images from the northeastern side itself, we can see the plasma depletion structures are appearing. These continuously move towards the west. For example, we see here it is seen in the northeastern region, and here it is in overhead zenith, and then it moves away from the zenith towards west. Similarly, we have another irregularity structure seen in these images, which has three branching kind of structures, tree-like branches. This is usually seen in case of the equatorial plasma bubbles, but we can see from these images in the mid-latitude transition region, these kind of features are seen also. Similarly, in the these images were before the midnight time up to 23:45. Similarly, after post-midnight time, the MSTID features which are propagating towards southwest can be seen in these images. The southwestward motion of the MSTIDs is consistent with the literature, as is seen in the other mid-latitude regions, that the MSTIDs are mostly propagating towards southwest during night times. Similarly, we have the plasma irregularity structures observed on 6th May 2019. These are similar kind of the images which were shown for the 5 May 2019, that is, these are 630 nanometer OI images. Top is north and right is the west. Again, we see that the image here with the three branching kind of structures in the initial stage, and here again another irregularity structure, that is the plasma depletion structure, which later bifurcates into two, and it again continues to propagate towards the westward direction. So this again, we have the another irregularity feature post-midnight over here. The post-midnight feature has no branching kind of structures associated with it. So these plasma irregularity structures are shown again for the 6 May 2019, and these represent the airglow images and geographic coordinates for this night. See, we can see the southwestward westward movement of these irregularities and or the plasma depletions. So these are the pixel correspondences into the kilometers. This is the y-axis represents the distance in kilometers, while 00 again represents the overhead Srinagar. So we can, from these geographic coordinated images, we can calculate the east-west spatial extensions, as well as from the running images, running images, we can calculate the phase, these drift velocity of these structures. Again, we do the kilogram analysis for these events. Like, for example, we have shown for the May 6th event that this is the zonal kilogram, where we have kept the north-south fixed, and we are seeing for the east-west motion. So this irregularity feature, these are moving towards west with time. So this is the time axis, and this is the east-west distance, with 00 representing the Srinagar, middle of the zenith, overhead zenith of the Srinagar. So we can see that these irregularity structures or plasma depletion structures are moving westward, while this is the meridional kilogram, which sees the north-south components of the motion. But we see that these are parallel to the time axis over here, and as such, there is no southward or northward component of these images. It is nearly zero. So we can conclude from these kilograms that these are moving towards west. And from these images, by the slope of this line, we can calculate the zonal drift velocity of the irregularity features. So the irregularity parameters which are calculated for the 5th May 2019 are given as follows. So these are the field aligned irregularity structures and one of the MSTIDS structure. This is the time of their observations shown over here. This is the east-west spatial extension in case of the field aligned irregularities and wavelength in case of the MSTID. The irregularities are seen with 190, 185, and 200 kilometers per extension, east-west extension. So this gives the zonal drift velocity, and this is the number of branchings. So we can see after midnight time, there is no branches are there. So, and the branching kind of structures moves with a greater drift velocity as compared to the ones which have the branchings, but all these field aligned irregularities are moving towards the west. There is an MSTID which moves towards southwest, and its horizontal phase velocity is 110 meters per second. Similarly, this is the irregularity parameter for these are the irregularity parameters for 6 May 2019, and we see all the four kinds of irregularities appearing in the field of view during this night. Again, we see that the number of branches here is 3, number of branches here is 2, and these move with the lesser zonal drift velocities as compared to the which have no branchings, which have 0 number of branchings. And the post we see in the 5 May 2019 event that near midnight there are no branchings, and again here after midnight there are no branchings, and the east-west spatial extension is also greater than that of the ones which have branching kind of structures. So the mesospheric gravity waves in the mesospheric and lower thermospheric regions are detected during the nights of these irregularity observations. So these are the airglow images of 840 and 557 nanometer images. The top, this is for 5 May, 840 nanometer image at 86 kilometer azimuth altitude, and this is the 557 nanometer altitude after some time of this image, but from 557 nanometer at 97 kilometer. From these images, we can see that the gravity waves are seen. And from the running images, we see that, which are not shown here, we can see that the gravity waves are firstly seen in these images, that is at 86 kilometer height, and later in the 97 kilometer altitude. And as such, we can say that the gravity waves are propagating upwards. Similarly, for 60 May night, we can see the gravity waves are again propagating upwards. So Srinagar is now this is the discussion of these observations. Srinagar is a low to mid latitude transition region which has a magnetic latitude of about 25.91 north. The ionospheric phenomena over this region are difficult to characterize in terms of their origin because both the equatorial plasma bubbles and the mid latitude irregularities can affect this transition region. In our present cases of observation, the depletions appear from the northeastern side of the imager. The irregularities move westward during geomagnetic quiet conditions, and which is not seen in case of the equatorial plasma bubbles, because irregularity plasma bubbles move westward only when the geomagnetic conditions are disturbed. So the usual motion of the equatorial plasma bubbles is eastward during the geomagnetic quiet periods. So there can be the role of atmospheric gravity waves, which can locally generate the these plasma depletions in the mid-latitude regions itself. So the plasma depletions are aligned along north-south direction with smaller eastward tilts, which is attributed to the large plasma drifts with increasing altitudes. The bifurcations of plasma depletions point towards lower latitude regions, which is opposite to that of the equatorial plasma bubbles. Plasma drift velocity gradients developed between higher and lower latitude portions of the bifurcating bands. The plasma depletions are thus believed to be locally generated in the mid-latitude regions and they extend towards the transition region. Similarly, we can see the post-midnight MSTID event for 5 May 2019 might be controlled by these field around irregularities. So this is the summary and conclusion now. The post-sunset plasma depletions are reported for the first time from Srinagar. In all the observed cases, we see the westward drifts. The large-scale plasma depletions occurred under geomagnetic quiet conditions. The gravity waves in the ML2 region might be one of the seeding mechanisms responsible for their origin. The east-west extensions, magnitude of the zonal drift velocities, and their existence with the finger-like bifurcation structures are similar to that of the equatorial plasma bubbles. The differences include the westward drifts, the bifurcations are pointing towards the equator, and they exist with the eastward tilts, which is opposite to that of the equatorial plasma bubbles, which during the geomagnetic quiet condition exist with the eastward drifts and have bifurcations pointing away from the equator, and they usually appear for they have westward tilts, which is not seen in case of these irregularity features seen over Srinagar. Thus, we conclude with a statement that we have an evidence of the mid-latitude irregularities reaching towards the transition region. And that's all for this presentation. I acknowledge, I pay my sincere thanks to my supervisor, Professor Manzur Ahmed Malik, and co-supervisor, Dr. T.K. Ramkwar, for their guidance and kind support. I'm grateful to DST for financial support under Ionospheric Fellowship Scheme. I'm also thankful to NARL for using National Atmospheric Research Laboratory, Galangi, Andhra Pradesh, for allowing use of their facilities and installation of All Sky Airglow Imager in the Srinagar. I'm grateful to the present director, NARL, Dr. A.K. Patra, for permitting my visit to NARL on 2 occasions and provision of local hospitality. Finally, I'm also grateful to COSPER organizers for selecting my abstract for this assembly and granting me the financial support to register for this meeting. So these are some